Welcome to lesson 7. Today we'll be covering geometric series. Let's get started. Okay, let's just derive the sum of a series formula. Let's figure out how the formula works. Okay, so what we're trying to find is the sum of a geometric series. It could be any geometric series. So algebraically speaking, the way we write geometric series is a plus ar squared plus dot 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 plus ar to the n minus 2 plus ar to the n minus 1. Ar to the n minus 1, you can think of it as the last term. So anyway, we want to find the sum of the first n terms, and that equals to the formula that you can see. Sum of the first n terms is a plus ar plus blah 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 ar to the n minus 1. I'm going to call this equation 1. When we do simultaneous equations, there's a first equation and a second equation, and you can do certain operations. You can do, second equation minus first equation and so on. That's basically what we're after. But anyway, for the time being, just understand, okay? I haven't done anything fancy here. I've just written this out the long way. Let's multiply both sides by r. So on the left-hand side, r multiplied by sum of the first n terms, s of n, r times sn. The right hand side, I'm going to multiply r with everything. Because I've multiplied everything on the left by r, I have to multiply everything on the right hand side by r. Okay, so just expanding this and you'll get r times a is ar, r times ar is ar squared, and so on and so forth. And the last term, r times ar to the n minus 1, this is where you need to pay attention. R to the n minus 1 means it's not r to the n, there's one less r. So if we multiply by r, it becomes ar to the n. Make sure you understand that. So anyway, we're going to call this equation number 2. And now we're going to subtract 2 from 1. So now we'll do number 1 minus number 2. So the first equation minus the second equation. So that minus that. Okay, so I've just written out first equation over here minus the second equation. Now, if you notice over here, right, AR and AR. So you have AR minus AR. Remember, we can only subtract like terms. So you can't do A minus AR. You can't do anything like that because they're not like terms. However, AR, you can subtract AR. It's like saying 5x plus 7 minus 3. You don't do 5x minus 3, it doesn't make sense. You do the like terms only. So AR minus AR, AR squared minus AR squared, and so on till AR to the n minus 1, AR to the n minus 1. Those will all cancel out, and you'll be left with A and AR to the n. So basically, Sn minus Rsn, so the first equation minus the second equation, the left-hand side will look like this, right? That minus that, that's the left-hand side. On the right hand side, after you've subtracted everything, cancelled everything out and so on, you're left with a minus ar to the n. A minus ar to the n. There were no like terms for these two to get cancelled out by, right? So a minus ar to the n. Let's factorize, right? What's common on the left hand side is s of n. What's common on the right hand side is a. Factorize it out. You get that? Remember, we are trying to find a formula for sum of the first n terms. So I want to make this the subject. In other words, I have to get rid of 1 minus r. So I'm going to divide both sides by 1 minus r. And there you have it. That is the formula for the sum of any geometric series. So let's looking at that in more detail. This is the formula for the sum of any geometric series. However, this is basically when r has an absolute value less than 1. When r is greater than 1, we write it like this. And there's nothing fancy, they're both the same thing. If you want, you can memorize only this one, you can memorize only that one. It's really up to you. The difference is, like, if r is more than 1, right, the bottom is going to be positive here. But if r is more than 1 over here, the bottom will be negative, denominator will be negative. And that causes a few issues. So just to avoid any silly mistakes, we just write it like this. They're both the same thing. All that's really been done is the top and the bottom both have been multiplied by negative 1, which doesn't change the fraction, right? So for example, if you have 2 over 4, that's a half, right? 2 over 4 is half. If you multiply top and bottom by the same number, the fraction doesn't change. If you multiply the top by 2 and the bottom by 2, you'll get 4 over 8, which is still half. So similarly, if you multiply 2 over 4 by negative 1, top and bottom, you get negative 2 over negative 4. That's still the same fraction. The negatives will cancel out. I haven't changed anything. Similarly over here, right? Multiply top and bottom by -1, you get that. So they're the exact same formula. There's nothing different. The only reason we write it like this is so that to avoid making silly mistakes, right? So when r is more than 1, when r is greater, if you take away 1, it's still going to be a positive denominator. And if r is less than 1, you'll do 1 minus a small number, 1 minus half, for example, and you'll be left with half at the bottom, which is positive. So we want a positive denominator, I guess. So if you want, you can memorize only the top formula, or you can memorize only the bottom formula. I recommend memorizing only the bottom one. And actually, don't be lazy. This is Rn minus 1, R minus 1. You just swap these two around. Just memorize both of them. Get used to it, I guess. It's not that hard. You're grown up. Just do it. It makes life easy. Stops you from making a silly mistake. You don't want to make a silly mistake and lose marks in the HSC. It's not worth it. Okay, visually, you might want to memorize it like this. It's just a lot more visual. It's exactly the same. 8 times the top, or you can do 8 times that. It's the same thing. It won't change the answer or anything. But 1 minus r, 1 minus r. You have 8 to the left and n as a power to the right on the top. And yeah, just memorize whatever works for you, I guess. But you do need to have it memorized. And just a word of caution, this formula in particular is extremely crucial for you to memorize. Because the arithmetic series and sequence and so on and so forth, that was only that topic. However, this formula you will use in repayments and investment questions, and on all of basically most of the harder questions in series and sequences. This is the main formula. So you really need to know this like the back of your hand. Alright, let's look at some example questions. Solve the following geometric sequence sums. And we need to find the first 8 terms. A, what's A? The first term is 1. What's R? 3 over 1, 3. So we know A is 1, and we know the common ratio is 3, and N is 8. So the sum of the first 8 terms is A, which is 1. R, which was 3, to the power of N, which is 8. A, R to the N minus 1 over R minus 1. Put in the calculator, you get the answer. Easy. Now looking at the next one, A, the first term, is X. And it is increasing by Y squared. So R is Y squared. Right? And N is 7. Substitute, put all the correct values in, simplify, and you'll get the answer. Fairly straight. I'm sure you can make this even more simple, But let's just keep it simple for now. As long as you can get to that stage, you're fine. Alright, so pause the video, do these questions, and the answers will be up in a second. So pause the video now, give it a go yourself. Just practice getting used to using this formula. Alright, I'm assuming you've paused and done all the questions, or at least the first one. These are the answers. Hopefully you did something great. If you couldn't figure out a certain question, please ask me on Slack. I'll be more than happy to show you the working out. Alright, so variations of example 1. This is basically everything you did over here, but slightly harder versions. What is the sum of that? Well, A is 2, R is 10. I think it's supposed to be 10. It's supposed to be 2. R is 2. So N is 10. I'm sorry, it's supposed to be N. N is 10. R, the common ratio is 2. Clearly it's 2. My mistake on my part, okay? So we have A, R, and N. We can easily use the sum formula, and you will get the answer of 2046. And similarly over here, okay, so the only real issue over here is how many terms are there? I guess that's fairly easy. There should be 10. But what about when it's like this? Slightly different. What is the sum of that? Well, we know A is 1. We know R is going to be half. It's multiplying by half every single time. But what's N? That's the real question. So if you want, you can think of it as like this. 2 to the 0, 2 to the 1, 2 to the... So 0 to 10, right? 2 to the 0, all the way to 2 to the 10. That gives us 11 terms. Because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10... plus the 0, that's 11 terms. Another way to think of it is 10 minus 0 is 10 plus 1 is 11. Because it's inclusive. Anytime you have two numbers which are inclusive, you can subtract them and add 1. For example, how many numbers between 5 and 10? You do 10 minus 5 is 5 plus 1, 6. Check it. 5, 6, 7, 8, 9, 10. There are 6 terms. Anyway, so if you do it like that, you know A, you know R, and you know that N is going to be 11. Sub it into the formula, put it into the calculator. So you have A, which was 1, R, which is half to the power of 11, minus 1 over R minus 1. This is the formula, subbing in the right values, and you get the answer. Fairly straightforward. Right, so this is where it starts to get a little tricky. The third term in the geometric progression is half, and the 8th term is 16. Find the sum of the first 6 terms. Okay, in series and sequences in general, you'll be given key information. You need to interpret that information. So the thing as the third term, right? So what is the formula for a term in a GP? AR to the n minus 1. So AR to the n minus 1 is AR, since it's the third term, it'll be 2 AR squared. AR squared is half. So we have converted this piece of information into algebraic form. You need to be able to do this. You cannot use a sum formula when it's telling you third term. Even though the question is find the sum of the first 6 terms. So this is a sum question, right? But to get to that stage, you need to interpret this information. And this information happens to be given to us in term, right? Third term, the 8th term. So we use the term formula. We get this. And that's clearly a simultaneous equation, right? So using simultaneous equations, T8 over T3 is equal to AR to the 7 over AR squared. A's will cancel out. R7 and R squared cancel out to R to the 5. And just subbing in what was the 8th term. 8th term was 16. Third term is a half. So 16 over a half is equal to R to the 5. So I put 16 there, put half here, and AR7, AR squared. The right hand side becomes R to the 5. The left hand side becomes 16 over 0.5. You can do it on a calculator, it'll give you 32. 32 is equal to R to the 5. Taking the fifth root, you get 2 is equal to R. Okay, so you have R. Now, as in all simultaneous equation questions, we're now going to sub in R value into either this or this, but this one looks a bit easier, so let's just use that. Sub it in, make A the subject, you get A is equal to an 8th. Fairly straightforward. Now I have A and R, and I also have some of the first 6 terms. I know N is 6. Use the formula, sub everything in. A, which is an 8th, R, which is 2 to the power of 6 to the n, A, R to the n, minus 1 over R minus 1. So it's just a formula, subbing in the values, put in the calculator, you get the answer. Alright, classwork number 2. Exactly the same question as the previous question. Give it a go yourself and see how you do. Pause the video now, give it a go. Alright, I'm assuming you gave it a go. And this is the answer. Should be fairly self-explanatory because it's exactly the same as the previous step. We converted, the terms into algebraic, like the algebraic expression for it, and we solve it simultaneously. Sub it back in to get A and R. We know N. Use the formula. Simplify. You get the answer. Okay, example question 3. When A is missing, when the first term is missing, sum of the first 4 terms of a GP is 390. The sum, not the term, not the fourth term. It's the sum of the first 4 terms. And the common ratio is 2/3. Find these 4 terms and then check your solution to verify the sum. Okay, so the sum of the first 4 terms of a GP is 390. I have to convert this into an algebraic equation. So we know the sum formula. Write it out and just put in whatever information we have, right? So we know it's equal to 390. 390 goes there. A, and because the common ratio is less than 1, we're going to use 1 minus R to the n, right? So 1 minus R, we know the ratio is 2/3 to the n, 4 because of the first 4 terms, and 1 minus R. Note, only A is missing. So if we rearrange this, simplify this, take it there, and so on and so forth, and we'll get A. Right, simplify it, and then multiply that over, divide, so on and so forth, and you get A is equal to 162. Now we have A and we have R, we can find the first 4 terms. First term is obviously going to be 162. Multiplied by R to get the second term, multiplied by R again, multiplied by R again, and you get the first 4 terms. Easy. And you can check your solution to verify the sum, add all these together, and make sure that you get 319. Alright, how many terms of the series? 9 plus 18 plus 36, blah blah blah. I needed to give a sum of 1143. So we know A, we can figure out R, we need to find N, right? Because 1143 is the actual sum, but how many terms will there be? N is missing. So we have A, we have R. This is some formula, submit everything you know. 2, that disappears, I guess. And 2 to the n minus 1, take the 1 over there, 2 to the n is 128. You can use guess and check or logs. Either way, the answer is fairly straightforward. I mean, 2, 4, 8, 16, 32, 64, and 28. There are 7 terms. Easy. Obviously, the harder questions will have, like, weirder numbers. Just use logs, or use guess and check if you haven't done logs yet. But, this is the method. Alright, so example 5, inequalities. What is the least number of terms of the series 7 plus 14 plus 28 plus blah 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 that need to be taken to give a sum greater than 1000? So we need to, this is the sequence. If you add them up, the total has to be more than 1000. How many terms do we need? Well, we know A, we can figure out R. Always start off every question by just writing A is equal to this, R is equal to this. And we need to know N. We need to find out N. N is missing. We don't know N. But we do know that the sum of the first N terms has to be 1000 or more. Right? So this is a formula. It has to be more than 1000. Simplify. And take the minus 1. Take it to the right hand side. You get plus 1. Now, if I take log, it's going to get a little ugly. So I'm going to combine these. You can do it on a calculator. And it'll do it for you. That becomes 1007 over 7. Now I'll take the logs. I take log of both sides. And yeah, put in my calculator. You get N is more than 7.168. Therefore N is going to be 8. You need 8 terms of this sequence such that the sum will become more than 1000. Alright, so a hybrid term in sum question, example 6. Now in some questions you will be given you'll be given one piece of information which will require you to use the term formula, and the second piece of information will require you to use the sum formula. So for example, the second term is negative 30. So AR is equal to negative 30. And the sum of the first 2 terms is negative 15. So we're going to use the sum formula for the second piece of information. However, we can do this in an easier way. So the second term is negative 30. Right? The sum of the first 2 terms is basically the first term and the second term added together, right? Is equal to negative 15. But we know the second term. Second term is negative 30, so I'm going to sub it in. The first term plus negative 30 is negative 15. So rearrange, and you get the first term is equal to 15. The first term is also known as A. So we know A, and we can figure out R because we know the first 2 terms. Just use the common ratio formula, T2 over T1. R is equal to negative 30 over 50. That's it. So you need to find A and R, and we found A and R is equal to negative 2. Alright, so this is if you remember from arithmetic series, there was a shortcut formula. If you knew the first term and the last term, you could figure out the sum fairly easily. N over 2 A plus L. There's something similar for geometric series. I'm not sure, it's never taught. I'm not sure why. I don't think it's in the syllabus either. So if you want to use this shortcut, you need to prove it in an exam before you can use it. But it's a good shortcut to check your work, I guess. And it's fairly straightforward. So anyway, let's just prove it first. So in case you do decide to memorize the proof and use it in an exam, at least you'll know what to do. So you have a generic series A plus AR plus blah blah blah. Sum of the series is the sum of the series formula. Now let's expand this out. So A minus AR to the n. So A, we expanded that bracket. That's all we've done. Nothing fancy. Now, what I'm trying to do is I'm trying to get the last term, right? Because I need the first and the last term. But I can't see a last term here. However, what I can do, the last term, remember, is AR to the n minus 1. So I need an AR to the n minus 1. The only place I can get that is over here. So what I'm going to do is, pay attention to this carefully. It's slightly tricky. So It's it's r to the n. What is that? It's r times r times r times r times r n times. There's n r's. I'm going to take one r out. So it becomes ar to the n minus 1. Right, because I've taken this r, there was n number of r's multiplying together. I took one of them out. Now there's n minus 1 r's multiplying together. ar to the n minus 1. ar to the n minus 1 is the nth term. Is T of n formula. Is the formula for the last term. So we have a, which is the first term, and we have the last term. But the last term has to multiply it with r. Okay, so a plus r times the last term over 1 minus r. And that's a shortcut you can use. First plus r times last over 1 minus r. And that's it. Now remember, if you are planning to use it in an exam, you do need to prove this. You need to write this whole proof out. You don't have to learn this. It's just something optional. I thought it was interesting. And it's a useful tool to check your work as well. Alright, so that's it. Do the homework, please.